Hello. I will explain the product of all natural numbers and the product of all prime numbers, which seem unlikely to be true. They can be found using the zeta function and the eta function. From the definition of the zeta function and the eta function, they can be differentiated, and find the zeta prime 0 and the eta prime 0. The definition of the zeta function is to add 1 over n to the power of s from n equals 1 to infinity. The zeta function converges in the region where s is greater than 1. The definition of the eta function is to add and subtract alternatively 1 over n to the power of s from n equals 1 to infinity. The eta function converges in the region where s is greater than 0. In addition, the eta function has the relation of 1 minus 2 to the power of 1 minus s with the zeta function above. If each term of the eta function is expressed again as 1 over n to the power of s minus 1 over n plus 1 to the power of s, the first term of the eta function is 1, so 1/2 comes first. This definition of the eta function converges in the region where s is greater than minus 1. Therefore, at s equals 0, inside the sum sign is 1 minus 1, which is 0, so eta 0 is 1/2. In general, eta 0 equals 1/2 is proven by geometric series. The geometric series is established in the region where the absolute value of x is less than 1. If x equals minus 1, the geometric series s equals eta 0 is 1/2. In the relation between the zeta function and the eta function above, if s equals 0, zeta 0 is minus eta 0. Therefore, zeta 0 is minus 1/2. It can be proven in various ways that zeta 0 equals minus 1/2, and it is also true for the zeta function for negative integers. In the relation between the zeta function and the eta function, when differentiating the eta function, 1 minus 2 to the power of 1, s in the parentheses is minus 2 to the power of 1, s times log 2. In addition, we add the differentiation of the zeta function. If we differentiate the eta function that converges in the region above where s is greater than minus 1, the first term 1/2 will be eliminated. If we differentiate 1 over n to the power of s minus 1 over n plus 1 to the power of s in the brackets, we get minus log n over n to the power of s plus log n plus 1 over n plus 1 to the power of s. Therefore, eta prime 0 becomes s equals 0. So the brackets are log n minus log n plus 1, which is the same as log n over log n plus 1. The negative log is the log of the reciprocal, and since the sum of logs is equal to the log of the product, it becomes the log of the Wallace product. The Wallace product is the product of an even number repeated twice over an odd number repeated twice, which is like pi over 2. Therefore, eta prime 0 is 1/2 log 2 pi over 2. This is equal to 2 times log 2 times zeta 0 minus zeta prime 0. Zeta 0 is minus 1/2, so it is minus log 2 minus zeta prime 0. Therefore, zeta prime 0 is minus 1/2 log 2 pi. We can find the product of all natural numbers from zeta prime 0. Differentiate the zeta function from the definition of the zeta function. 1 over n to the s power is minus log n over n to the s power. Therefore, zeta prime 0 is equal to minus the sum of log n from 1 to infinity. Since the sum of logs is equal to the log of the product, it is equal to minus the log of the product from 1 to infinity. Zeta prime 0 is minus 1/2 times log 2 pi, so minus log root 2 pi. Therefore, the product of all natural numbers is root 2 pi. As above, we can find the product of all prime numbers. The zeta function can be expressed as the Euler product, and the Euler product is the reciprocal of 1 minus 1 over the prime number of the power of s. This is the definition of the Euler product, and the zeta function is related to the product of prime numbers. If we take the log of the zeta function and the Euler product above, we can express 1 minus 1 over the prime number to the power of ks in the log as a Taylor series. The logarithm of the zeta function is 1 over k times the prime number to the power of ks from k equals 1 to infinity for every prime number. The above zeta function can be expressed again as an exponential function, and the zeta function is differentiated. The differentiation of the exponential function is an exponential function, but the sum in parentheses is differentiated. K is eliminated and it is equal to minus log p over p to the power of ks. Therefore, zeta prime s can be expressed as the differentiated part above times zeta s. If zeta s is not 0, then zeta prime s over zeta s is the sum of prime number to the power of minus ks times log p form k equals 1 to infinity. Zeta prime 0 over zeta 0 is equal to the sum of the logarithms of all prime numbers from k equals 1 to infinity, which is the sum of the logarithms of all prime numbers multiplied by zeta 0. Zeta 0 is minus 1/2, and zeta prime 0 is minus 1/2 times log 2 pi. So we can find the sum of logs of all prime numbers. Therefore, the sum of the logs of all primes is 2 times log 2 pi. The sum of the logs of all prime numbers is equal to the log of the product of all prime numbers. The product of all prime numbers above is 4 times pi squared.